Welcome, geometry students, to the review sheet, page 313, page 317. Let's go ahead and get started with the review sheet. Here we go. Numbers 1 through 4. The directions say to decide whether the figure is a polygon, and if it is, whether it's convex or concave. So here we go. Let's go ahead and get started. Numbers 1 and 2. Is number 1 a polygon? Yes, it is. We have all straight lines, segments, and all the segments intersect at their endpoints. So yes, it's a polygon. It is a concave polygon because see the indentation right here. There's an indentation. Okay, another way to know this is if you draw a line, if there's at least one place where you can draw a line through the polygon in such a way that it intersects more than two sides, it's concave. Well, if I draw a line right here, if I can do this right, guys, if I draw a line right here, if I draw a line right there, it intersects in 1, 2, 3, 4 places. That is a concave polygon. Okay, number 2 is not a polygon because I have a curved side here. It's not made up of segments. Okay, number 3, I have a polygon, definitely a polygon, and it's convex. Okay, convex because there's no indentations anywhere. So yes, a polygon, and it's convex. Number 4, yes, I have a polygon. I have all segments, and notice all the segments are intersecting at their endpoints. So I have all segments. Yes, I have a polygon, and it's concave. Okay, notice, look students, notice all of the indentations. Here's an indentation, here's an indentation, here's an indentation, here's one, okay? Plus, if there's just one place where I can draw a line that intersects the polygon in more than 2 places, then it is a concave polygon right here. Look at that. I draw a line there, intersects at 1, 2, 3, 4, 5, 6 places, okay? So this is a polygon, and they say non-convex. I say concave. Same thing. Okay. Alright, moving on to number 5. 5 through 8, the directions say to classify the polygon as equilateral, equiangular, or regular. Okay. Let's take a look at number 5. First of all, are all of the angles congruent? Yes. Second of all, are all of the sides congruent? No. This side here has 2 marks. This side here has 1 mark. So we have an equiangular polygon. Number 6. Are all the angles equal or congruent? Well, we don't know, but we're going to assume they're not. Notice all the sides are congruent. So if all the sides are congruent, we call that an equilateral. Equilateral polygon. Okay. Alright, moving on to number 7. Okay, notice here all the sides are congruent, so we call this an equilateral triangle. Number 8. Notice on number 8, all of the sides are congruent, and notice all of the angles are congruent. So it's equiangular and it's equilateral. We call that regular. Okay, whenever a polygon is equiangular and equilateral both, we call that a regular polygon, okay? A regular polygon. Okay, moving on to numbers 9 through 13. Actually, 9 through 12. You are given the number of sides of a regular polygon. Now, students, listen to me. Keyword, regular polygon. So for numbers 9 through 12, we're dealing with regular polygons. That means all of the what? Angles are congruent. Now we know the sides are congruent too, but we don't care about sides right now. All of the angles are congruent. So with that in mind, number 9, we know we have 5 sides, okay? So how do I find the total of all the angles on the inside? N minus 2 times 180. Okay, that's how I find the sum of the 5 interior angles. How do I know there's 5 interior angles? Because how many sides do I have? 5. I have 5 interior angles. I have 5 exterior angles, okay? So 180 times 5 minus times 3, 540. So there's the sum of all 5 interior angles. So how do I find one of those angles? Well, how many interior angles do I have? 5. They're all congruent. So take 540, which is the sum of all 5 angles, and divide by 5, and you will get 108. Okay? And all 4 of these problems are done the same way. Now listen, students, they also want us to find the measurement of the exterior angle. Now listen, how many sides does this polygon have? 5. How many interior angles does it have? 5. How many exterior angles does it have? 5. What is the sum of the exterior angles of a convex polygon? It's the same, remember. It never changes. Now students, please don't forget that. The sum of the exterior angles of a convex polygon never changes. It's 360. Now, it's regular, so all of my exterior angles will also be what? Congruent. So how many do I have? 5 divided by 5, and you get 72. So there's your 2 answers, okay? This is the measurement of one interior angle. This is the measurement of one exterior angle. All these problems will be done the same way. Number 10, we have 15 sides. Okay, so we have how many sides? 15. How many exterior angles? 15. How many interior angles? 15. All of these angles, all the exterior angles are congruent. All of the interior angles are what? Congruent. How do I know that? Because I'm dealing with a regular polygon. Okay, now what's the sum of the interior angles? Well, 180 and minus 2. So 15 minus 2, which is 13. So 180 times 13. 180 times 13 is 2,340. So there's the sum of all the interior angles, okay? Now, divide that by 15, because how many interior angles do I have? 15. So 2,340 divided by 15 will give you 156. So one interior angle is 156 degrees. Now, what is the sum of all the exterior angles? 360. It never changes. How many exterior angles do I have? 15. So divide by 15. 360 divided by 15 gives you, hold on 1 second, please. Gives you 24. So the measure of one exterior angle would be 24 degrees. The measure of one interior angle would be 156. Okay, number 11. We have 16 sides, so that means we have 16 interior angles. We have 16 exterior angles. All of the interior angles are congruent. All of the exterior angles are congruent. How do we know that? Because we're dealing with a regular polygon. If it wasn't regular, then we could not say they were congruent. Okay? Alright. So what is the sum of the interior angles? Well, 180 times 16 minus 2. So 180 times 14, which gives you 2,520. Now that's the sum of the interior angles. Now how many interior angles do I have? 16. So divided by 16. And you will get 157.5. So the measure of one interior angle is 157.5 degrees. Okay? Now moving on. What is the sum of my exterior angles? Well, that never changes. 360. How many exterior angles do I have? 16. So divide that by 16. So 360 divided by 16 gives you 22.5. So one exterior angle is 22.5 degrees. Okay, moving on to number 12. Okay, we have 9 sides, okay? So if I have 9 sides, I have 9 interior angles. And I have 9 exterior angles. All of my interior angles are congruent. All of my exterior angles are congruent because I have a regular polygon. Okay, what is the sum of my interior angles? 180 times n minus 2. So 180 times 7. 1,260. So 1,260 is the sum of my interior angles. How many interior angles do I have? 9. So divide that by 9, and you will get 140. So one interior angle equals 140 degrees. Now, what is the sum of my exterior angles? 360. How many exterior angles do I have? 9. So divide that by 9, and you will get 40. One exterior angle is 40 degrees. Okay, moving on to numbers 13 through 16. Now these problems here are a little more difficult, okay? So 13 through 16. You are given the measure of the interior angle of a regular polygon. How many sides does it have? Now guys, think about this. Let me show you something, okay? Watch this. Forget these problems here for just a second, okay? Forget these. Now look. Let's say I had a pentagon down here, okay? A regular pentagon. Not a very good drawing, but you get the point, okay? Now, look. All of these angles together would be what? 540 degrees. 180 times 5 minus 2. Okay? So all these angles together would be, what did I just say? 540. Now, how would I find one of those angles? I would divide by what? 5, right? Sure I would. So now, apply that to these problems here. Guys, think about it. See this 5 right here? Pretend you didn't know this 5, okay? Look, guys, 540 degrees equals, watch this, please, 540 degrees equals this right here, okay? Now, how do I get out one angle? I divide this by what? 5, or in other words, I divide this by what? 5. So I take this whole top here, which is 540, and divide it by 5. Now look at this. Do you not notice what they have in common here? A 5 and a 5. The sides, the number of sides. So really I can say 180 times my number of sides, we'll call it n, divided by what? 5, my number of sides, n. And that would give me one of my angles right here. Now, some of you understood what I just said, and some of you didn't. For those that don't understand what I just said, then just memorize this formula. Just memorize it, okay? So here we go. This is the formula you're going to use for these types of problems here, okay? So what type of problems am I talking about? The problems that say, hey, I'm giving you the measurement of one interior angle. Tell me how many sides you have in the polygon, okay? So here's the formula we're going to use. And once you know that formula, it's really quite easy, guys. Look, 180 n minus 2 divided by n equals 172. Now, multiply both sides by n. These cancel, leaving you with 180 n minus 2. 172 times n is 172n. Now take your 180, multiply it through. 180 times n. 180 times 2. Bring down your 172n. Now bring this over and make it negative. And we're left with negative 360 equals negative 8. Okay? N. Alright, so let's see. And by the way, if you struggle with any of your sign numbers, use your calculator, okay? So 360 divided by 8 is going to give you 45. Alright? So it's a really big polygon. It's a polygon that has 45 sides. Okay? Alright, here we go. Moving on. Okay, there's your formula. Equals 135. Okay, multiply both sides by n. If we multiply this side by n, the n's cancel. Multiply this side by n. 135 times n is 135n. Now take your 180 and multiply it through. 180n minus 360. Bring the 180 over, make it negative, and you're left with negative 360 equals negative 45. So 360 divided by 45 will give you 8. Alright, so 8. The number of sides we have would be 8. Alright, moving on to number 15. Okay, here's our formula we're going to use. That equals 150. Multiply both sides by n, and we're left with 180. N minus 2 equals 150n. Now take your 180 and multiply it through. 180 times n is 180n. 180 times negative 2 is negative 360. Bring your 180 over, make it negative. 150 minus 180 is negative 30. Now we have 360 divided by 30 would be 12. 12 equals n. So this polygon has 12 sides. Okay, number 16. Okay, there's your formula. Equals 170. Okay, let's multiply both sides by n. Now take your 180 and multiply it through. 180 times n and 180 times negative 2. Bring your 180 over, make it negative. 170 minus 180 is negative 10. Now divide both sides by negative 10. 36 equals n is the answer. So this polygon has 36 sides. Okay, moving on to number 17 through 20. Okay, the directions say use the diagram of parallelogram DEFG at the right. So this is, students, a parallelogram, okay? So here we go. DH is 5. So this line here is 5. What is HF? Well, guys, we know in a parallelogram the diagonals bisect each other. So if DH is 5, then HF is also 5. Okay? Alright, number 18. Angle GDE is 60. GDE. So this whole angle here is 60. The whole angle. What is the measure of EFG? Over here, well guys, in a parallelogram, opposite angles are always congruent, so this would also have to be 60 degrees. Okay, number 19. The measure of angle DEF is 115. What is the measure of EFG? EFG, this angle here. Well, students, we've learned that consecutive angles, that means angles that are side by side, consecutive angles in a parallelogram, are supplementary. So this angle here would have to be 65. Why? Because 115 plus 65 equals 180. So this angle here has to be 65. Okay, moving on, number 20. GH is 2. So from here to here is 2. Now remember, in a parallelogram, diagonals bisect each other. So if this is 2, then HE would also have to be 2. They want to know the length of GE. So from here all the way to here, well, that's 2 plus 2. The answer is 4. Okay, 4. Alright, moving on to numbers 21 through 26. Okay, here's the question they're asking. Do we have enough information to state for sure that we have a parallelogram. So let's find out. Here we go. Number 21. PS is congruent to QR. Okay, PS is parallel to QR. Okay, the answer is yes. We definitely have a parallelogram. How do I know that? We had a theorem that said if two sides are both what? Congruent and parallel, then we have a parallelogram. So yes, we know it's a parallelogram, and that's the reason why right there. Okay, moving on to number 22. Number 22. PTS, this triangle here, is congruent to triangle RTQ. Well, if that's true, let's quickly label all the congruencies that we know, okay? PT is your first two letters. PT is congruent to RT. So PT is congruent to RT. Let's see. ST is congruent to TQ. Well, that's enough right there. We're done. We're done. We learned that if in a quadrilateral, if the diagonals do what? Do you remember? If they bisect each other, then you have a what? A parallelogram. Well, look, they bisect each other. This segment here is congruent to this segment here. This segment here is congruent to this segment here. So yes, we have enough information. And the reason is the diagonals bisect each other. Okay, moving on to number 23. Triangle PQR. Is congruent to triangle RSP. Well, let's mark some congruencies here, okay? I would think that PS is congruent to QR. Yes, PS, QR. And I would think that PQ is congruent to SR. Let's see. PQ, SR. Yep. So guys, we're done. Yes, there's enough information, definitely. And how do I know that? Because we had a theorem that said what? If both sets of opposite sides are what? Congruent, then you have a what? Parallelogram. Now you see, guys, why it was so important you learn the different ways to prove that we have a parallelogram, okay? You have to know that. Notice how the opposite sides are congruent. This side is congruent to this side. This side is congruent to this side. Okay? Alright, moving on to number 24. Okay, PQ is congruent to SR. And PS is congruent to QR. Well, guys, we just covered that. Yes, we definitely know we have a parallelogram. Definitely. Because both sets of opposite sides are congruent. Both sets of opposite sides are congruent. Okay? Moving on to number 25. Angle SPQ. This angle here is congruent to angle QRS. Angle PQR. This angle here is congruent to angle RSP. So yes, I definitely have a parallelogram. So we have a theorem that said this. If both sets of opposite angles are congruent, then you have a parallelogram. And look, both sets of opposite angles are congruent. So yes, I have a parallelogram. Okay, number 26. Number 26. Angle PSR, this angle here, plus SRQ, this angle here, equals 180. Now, look guys, the best way to do this is to put numbers in there, okay? So that's what I'm going to do. I'm just going to make something up. I'm going to call this 100. This angle here, and I'm going to call this angle here 80. Okay? Now look, angle PSR, this angle here, is congruent to angle RQP, this angle here. So if they're congruent, and this is 100 degrees over here, then this angle over here has to be 100 degrees also. So this angle here is degrees. So do I have a parallelogram? Yes, definitely. Yes, yes. How do I know that? Guys, we learned a theorem. We learned this theorem that said this. If one angle is supplementary to both of its consecutive angles, consecutive means side-by-side angles. So if one angle is supplementary to both of its consecutive angles, then we know for sure that we have a parallelogram. So yes, we do, because one angle is supplementary to both of its consecutive angles. Alright, okay, moving on to number 27. Okay, the directions for 27 through 30 say each figure is a parallelogram, so we know that. Tell us if it's a square, rectangle, or rhombus, okay? Well, first of all, we have a parallelogram here in which all four sides are congruent. Now, it might be a square, but we don't know for sure. What we do know for sure is a rhombus is a parallelogram that has four congruent sides. So 27 is a rhombus. Let me say that again. A rhombus is a parallelogram that has four congruent sides. Now, 28, we have a parallelogram. They already told us that. We have diagonals that are bisecting angles. This angle is congruent to this angle. 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 We have diagonals that are bisecting angles, and we learned that a rhombus has diagonals. A rhombus has diagonals that bisect angles, so this has to be a rhombus, okay? Alright, number 29 and 30. Okay, now notice here, guys, look. Remember, I have a parallelogram, okay? So if I have a parallelogram, then I know for sure that was given to us in the directions. The directions said you have a parallelogram. So if we have a parallelogram, we know opposite angles are congruent. So if this is 90, this has to be 90 also. And also in a parallelogram, we know consecutive angles are supplementary. And these two angles here are consecutive. They're side by side. So if this angle here is 90, then 90 plus 90 is 180. This angle has to be 180. This angle here has to be 90. Now if this angle is 90 in a parallelogram, opposite angles are congruent. So this angle over here has to be 90. So look what we have. We have four congruent sides and four right angles. That's a square, guys. A square is a parallelogram with four congruent sides and four right angles. Now look over here. Notice that we have this line here, congruent to this line here, congruent to this line here, congruent to this line here. Let's put some numbers there to help us. Let's pretend this segment here is 8. Which means this segment here is 8. Which means this segment here is 8. Which means this segment here is 8. So my whole diagonal here is 16. And my whole diagonal here is 16. Now we learned that when a parallelogram has congruent diagonals, we have a rectangle. That was one of the ways I taught you to prove that a parallelogram is a rectangle, is when the diagonals are congruent. Okay? Alright, moving on. Number 43. And do we have a picture of this or not? We don't, do we? Oh, boy, I should have had a picture. Okay, well, I'm going to try to draw it for you down here. I apologize, guys. Okay, here we go. Do this real quick here. Here's the stairs right here. And we have the railing going up right here. Can't believe I forgot to put this in here, guys. I apologize. Alright, let's see here. Here's the railing. About right here. Now, let's see. We have a red parallelogram. Angles 1, 2, 3, and 4. 1, 2, 3, we got a green parallelogram right here. And let's see, those angles are 5, 6, 7, 8. So 5, 6, 7, 8. That's the best I can do, guys. Okay, here we go. Which angle in the red parallelogram is congruent to 1? Well, students, that's really simple. In a parallelogram, opposite angles are congruent. So 1 and 4 are congruent. So angle 4 is the answer. Okay, moving on to number 44. Which angles in the green parallelogram are submaterial to 6? So here's 6, right? Which angles in the green parallelogram are submaterial to 6? Well, we've learned that consecutive angles are submaterial angles that are side by side. So 5 would be submaterial to 6, and 7 would be submaterial to 6. So angles 5 and 7. Angles 5 and 7. Okay, moving on to number 45. Which postulate in chapter 2 can be used to prove that 1 is congruent to 5? Now look, here's 1 in a red parallelogram. Here's 5 in the green parallelogram. How do I know those two angles are congruent? Well, here's how I know, guys. Look, I have a line here. I have a line here and a line here that are parallel, and they're cut by a transversal. Whenever two parallel lines are cut by a transversal, corresponding angles are congruent, and those are corresponding angles. Okay, so which postulate can I use? Well, the postulate that says, hold on one second. The postulate that says corresponding angles are congruent. Okay. Alright, number 46. Is the red parallelogram congruent to the green? Not at all, guys. Not at all. Look at the side right here, look. The red one starts here, ends here. Well, the green one ends here, but it starts way up here. This side's longer, okay? And this side's longer than this side too. No, they are not congruent, because the balusters or the spindles or these railing posts here are not congruent. They're different lengths, okay? Alright, moving on to number 47. A rhombus is a parallelogram. Now, the directions say to, but always, sometimes, or never. A rhombus is a parallelogram. Well, guys, that's always true. That's the definition of a rhombus. A rhombus is a parallelogram. A square is a parallelogram. Well, guys, of course, a square is a parallelogram with 4 right angles and 4 congruent sides. So yes, a square is a parallelogram. Always. Yes. A rectangle is always a square. No, not always. Sometimes, okay? This is a rectangle right here. And that's not a square. This is a rectangle here. And that's a square. So a rectangle is sometimes a square. Now, a square is always a rectangle. Okay? Alright. Now, we did not talk about a kite. That's in the last lesson we didn't get to. And that's fine. I'll go ahead and answer the question. Here's what a kite is. The definition of a geometry, you do not need to know this. You don't need to sit back and watch, okay? You don't have to know this, okay? The definition of a geometrical kite is consecutive sides are congruent. You have two, let me rephrase that. You have 2 pairs of consecutive congruent sides. So they have to be consecutive. So this side here is congruent to this side here, and this side here is congruent to this side here. And by the way, you cannot have 4 congruent sides in a kite. You cannot do that, okay? You cannot have 4 congruent sides. It has to look like this, okay? So is a kite ever a rhombus? No, never. A kite is never a rhombus, because a rhombus needs what? 4 congruent sides. So a kite is never a rhombus. Never. Okay? Alright. Moving on to kind of fill this in, okay? That's fine. We're going to do really fast, okay? Notice, first of all, we're dealing with a parallelogram. See it? Parallelogram. So question number one, if you'll look down at the bottom of page 316, you'll see little cards numbered 1 through 11, okay? Number 1 says opposite sides are parallel. Is that always true with a rectangle? Are opposite sides parallel? Yes, because a rectangle is a parallelogram. So yes. Okay, number 2, opposite angles are congruent. Yes, guys, look. A rectangle is a parallelogram. And what do we know about parallelograms? Opposite angles are congruent. Yes. Okay, number 3. Opposite sides are congruent. Yes. A rectangle is a parallelogram, and a parallelogram, opposite sides are congruent. Yes. Okay, number 4. All sides are congruent. No, a rectangle does not have 4 congruent sides. I mean, it might, but it doesn't have to, so no. Number 5, has 4 right angles. Yes, the definition of a rectangle is a parallelogram with 4 right angles. Number 6, at least one pair of opposite sides is congruent. At least one pair. Yes, definitely. At least one pair is congruent. Yes. Okay, number 7, diagonals are congruent. For a rectangle, yes. In a rectangle, diagonals are congruent. Number 8, diagonals bisect each other. Well, yes, diagonals bisect each other because a rectangle is a what? A rectangle is a parallelogram. Don't forget that, guys. A rectangle is a parallelogram. And in a parallelogram, diagonals bisect each other. So yes. Number 9, diagonals are perpendicular. No, maybe, but not necessarily. Number 10, diagonals bisect vertices. Well, sometimes, but not always. No, not in a rectangle. Okay. Now, if the rectangle was a square, then you have a rhombus too, and then the diagonals would bisect angles. Okay, but not necessarily in a rectangle. No. Okay, number 11. Diagonals divide into congruent triangles. Yes, that is true, definitely. Yes. Yes, that is true. Okay, moving on to a parallelogram. Here it is right here. Column number 2, parallelogram. Here we go, number 1. Opposite sides are parallel. Yes, definitely. Number 2, opposite angles are congruent. Yes, in a parallelogram. Number 3, opposite sides are congruent. Yes, in a parallelogram. Number 4, all sides are congruent. Not necessarily, no. Number 5, has 4 right angles. Not necessarily, no. It can, but we don't know for sure. Number 6, at least one pair of opposing sides. At least one pair of opposite sides is congruent. Yes, that is true. At least one pair is congruent. Yes. Number 7, diagonals are congruent. No, not necessarily. No. Only in a rectangle. Number 8, diagonals bisect each other. Yes, in a parallelogram, diagonals bisect each other. Number 9, diagonals are perpendicular. No, in a rhombus they are. Not necessarily in this parallelogram. Number 10, diagonals bisect vertices. Again, maybe if the parallelogram was a rhombus, but we don't know that. We're just talking about a parallelogram. And no, in a parallelogram, the diagonals do not always bisect the angles. No. Number 11, diagonals divide into congruent triangles. Yes, definitely. Definitely. In a parallelogram, if you draw diagonals, you will have 2 sets of congruent triangles. This triangle here is congruent to this triangle here, and this triangle over here is congruent to this triangle here. Okay, next is, now look carefully, guys. Next would be a square. So let's go ahead and draw our square here. Here's our square. And here we we go. Question number 1. Opposite sides are parallel. Yes, because don't forget, a square is also a what? Parallelogram is also what? A rhombus. Okay, so yes, definitely opposite sides are parallel. Number 2, opposite angles are congruent. Yes, in a parallelogram they're congruent. Number 3, opposite sides are congruent. Okay, yes, that is true. Opposite sides are congruent. Yes, in a parallelogram. Number 4, all sides are congruent. Yes, because a square has 4 congruent sides. Yes. Number 5, has 4 right angles. Yes, it is a square. A square is a parallelogram with 4 congruent sides and 4 right angles. Number 6, at least one pair of opposite sides is congruent. Yes, that is true. Number 7, diagonals are congruent. Yes, in a square. Yes. Don't forget that a square is also, I forgot to say this, sorry guys, a square is also a rectangle, sorry about that. So yes, the diagonals are congruent, because in a rectangle, diagonals are congruent. Number 8, diagonals bisect each other. Yes, because a square is a parallelogram, and parallelograms have diagonals that bisect each other. Number 9, diagonals are perpendicular. Let's see, in a rhombus, the diagonals are perpendicular, and a square is a rhombus, so yes. Number 10, diagonals bisect vertices. Well, remember, a square is a rhombus, and when you have a rhombus, the diagonals always bisect the vertices, so yes. Number 11, diagonals divide into congruent triangles. Well, certainly. Here's your diagonal here. Here's your diagonal here. Yes, this triangle here is congruent to this triangle here. This triangle here is congruent to this triangle here. So the answer is, yes. There we go, yes. Okay, moving on now to a rhombus. Okay, a rhombus right here. A rhombus. So we have a rhombus, which is also a what? A parallelogram, okay? So here's your rhombus here. All that you need for a rhombus is a parallelogram with 4 congruent sides. That's it. Okay, alright. Question number 1. Opposite sides are parallel. Yes, because a rhombus is a parallelogram. So yes, opposite sides are parallel. Number 2. Opposite angles are congruent. Well, yes, a rhombus is a parallelogram. Parallelograms have opposite angles congruent. Number 3. Number 3 is opposite sides are congruent. Yes, in a rhombus, all 4 sides are congruent. So yes, opposite sides are congruent. Number 4, all sides are congruent. Yes, all 4 sides are congruent. Yes. Number 5, has 4 right angles. No, not necessarily. No. Number 6, at least one pair of opposite sides is congruent. Yes. That is definitely true. At least one set of opposite sides is congruent. Number 7, diagonals are congruent. No. It's a parallelogram. The diagonals bisect each other, but they are not necessarily congruent. No. Number 8, diagonals bisect each other. Yes, because a rhombus is a parallelogram, and parallelograms have diagonals that bisect each other, so yes. Number 9, diagonals are perpendicular. In a rhombus, the diagonals are always perpendicular. Yes. Number 10, diagonals bisect vertices. In a rhombus, the diagonals always bisect the vertices. Always. So yes. And then number 11, diagonals divide into congruent triangles. And yes, that's true, because we have a parallelogram. So this triangle here is congruent to this triangle here, and this triangle here is congruent to this triangle over here. So the answer is yes, okay? Now students, don't forget, we will get into trapezoids later, okay guys? So I'm not worried about doing this column here. We'll get to trapezoids later. Okay, moving on to numbers 1 through 12. 1 through 12. Here's how we're going to do this, guys. I should have put all these on one page. How can we do this real quick here? Let me see. Okay, students, so here we go. Here's what we're going to do. I went ahead and condensed numbers 1 through 6 down to the same page here, okay? So here we go. Look, instead of going through each figure, I'm going to do this. I'm going to do something a little different. Non-convex means concave. Okay? So, let's go through and find all the concave polygons and put the letter A with them. That's convex, convex, convex. Here's concave right here. Indentation right here. So we're going to put letter A right here. And also, here's concave, so we'll put an A with letter 5. Letter A with 5. Okay, cross off A. Let's go on to B, equilateral. Okay, are all the sides congruent here? No. Here all the sides are congruent, so we'll put a B here. Here all the sides are congruent, so we'll put a B here. Here all the sides are congruent, so we'll put a B here. And that's it. Okay, moving on to letter C. Letter C, decagon. That means 10 sides. 10 sides. A decagon is 10 sides. Well, let's see. No, no, no. Here's 1, 1, 2, 3, 4, 5, 6, 9, 10. This is a decagon right here. There's 10 sides. So we're going to call this also letter C. This is not a decagon, and this is not a decagon. Let's cross that off. Now on to letter D, equiangular. So we're looking now for polygons that have congruent angles. Well, here's one. All of the angles are congruent. So D. Not here, not here, not here. Here, all of the angles are congruent. So D. Okay? Now let's go on to E, heptagon. Okay? Now think about what is a heptagon. A heptagon is a 7-sided figure. Well, the only 7-sided figure up here I see is this one right here. You can go through and count each one, but trust me, this is the only one. So E. And then F, regular. Now if it's regular, it has to be B and D both. Equilateral and equiangular. Well, 2 is B and D, so I'm going to go and put an F here. I don't see any other B or D's. A B and D together. So I think this is it. Let's see how we did. This should be letter E. Did not mean to do that. Okay, here we go. This should be letter E. That's right. This should be BDF. That's right. This should be B. Yep. This should be ABC. Yep. This should be A. Yep. And this should be D. Okay, very good. Moving on to number 7 through 12, and I believe we're finally finished. 7 through 12, so here we go. Okay, now look carefully, students. Look, BDFHJ is regular. Let me highlight that for you. BDF. Is regular. Now that's a pentagon. 5-sided regular, okay? It says it's divided into 5 congruent triangles, okay? Let's see, the 5 other triangles are isosceles. Let's see. So these triangles here with 1 dot are isosceles. Let's see. They are congruent to each other, and they are isosceles. Okay. Now, let's see. The 5 outer triangles are not congruent to the 5 inner triangles. Okay, very good. Now, angle BJH equals what? Well, let's use a different color. Here's B, over to J, and down to H. So this angle here, now guys, think about it, come on. That's an interior angle of your pentagon. Here's your pentagon. There's your pentagon. And then once to find that angle there, well guys, if we use our formula, we find out that all the interior angles add up to 540. Okay, now there's 5 interior angles, so take 540 divided by 5, and you will get 108. Okay, so 108. Now moving on to number 9, the measure of angle JOB. Hold on 1 second here, guys. Let's get rid of this here. There we go. Okay, the angle, measure of angle JOB, job. Okay, here's J to O to B. Now guys, come on, think about it. Look, inside here, all 5 of these angles make a complete circle. That means if you add up all 5 of those angles there, you'll get 360, okay? So this angle here would be 360. How many angles are there? 1, 2, 3, 4, 5. So 360 divided by 5, which would give you 72 degrees. So that angle there would be 72 degrees. Okay, now identify the polygon AB. Identify the polygon ABC all the way around. Well guys, that's 10 sides. Okay, add up all the sides. That's 10 sides. So we have a decagon. Okay, not too difficult. We have a decagon. Okay, moving on to number 10. How do we know that ABOJ is a kite? ABOJ, okay, right here. Use blue. Here's A, B, O, J. How do I know that's a kite? Because look right here, guys. The 5 outer triangles are not congruent to the 5 inner triangles. That means this triangle here is not congruent to this triangle here. Yet we know that this side here is congruent to this side here, and we know this side here is congruent to this side here. Now I know we've not covered kites yet, so don't worry about that, but I still want to answer the question for you, okay? Alright, moving on to this. ABOJ. Now watch carefully, guys. Come on. ABOJ. This polygon here is congruent to polygon what? CB, and then what? OD. CBOD. So this should be OD. CBOD. Alright, now BJHO. So BJHO. So that polygon there is congruent to polygon DF. So here we go. DFHO. So DFHO. So it should be HO right here. There it is. Okay. Alright guys, I know it's been a pretty long video. I hope this homework help video or review sheet help video has been a help to you. If you have any questions, don't hesitate to call or email.